出てこないから何言ってるやめてよ。
Hello everyone, good evening. Share screen. Window. Okay, so now I only have one. Now I only have one screen only. So that is why I was like only able to share one screen only. So if anything, I because when I activate like this, I cannot really this one. So if you can hear me, can you please at least leave a message so that I know that you can hear me well? Please let me know if you can hear me well. Okay, so wait. Wait a second. Wait. Can you like give me 1 minute? Okay, so because I haven't really shared the screen, I even haven't really shared the answer inside there. Okay, so I'm about to update the this one, my comment. Okay, so thank you very much for helping me. Okay, so can you give me like 1 more minute? Because I want to upload the answer for this technique menjawab. Hopefully you all can get it. Sorry, give me 1 moment. I accidentally forgotten. Okay, so okay, welcome everyone to my technique menjawab. I hope that you all are ready with the questions today. So okay, now as for the suggested answer, okay. Give me 1 more minute. I'm so sorry. I should have uploaded this. Here. Okay. Now, if you see my comment down to the YouTube there, you can you see the link to the answer? Can you see the link to the answer? Because I just upload the link to the answer so that you don't have to copy anything. Today you just basically this one. Do you see the link to the answer? It's a PDF file with the this one. Yes, okay, very good. So I guess that will be the answer for our presentation today, and you do not have to copy anything. So without further ado, shall we begin? So I might not see your comment in the coming future. So please pardon me if I cannot see your comment. Because I am now going. I will be going on the this one because I don't have extra screen. You see my environment. I actually in my room in the UKM there. And another worries is I might worry that the line might be cut off suddenly. Okay, so if I cannot present well, so please pardon me on that lah. So welcome to another talk for semester 2. So as you already know that every semester around this time I will do one technique menjawab, and I'm so sorry for this year I'm doing a little late due to workload over here, and the line of is not stable. So I hope that I still can help you as much as I can. So I'm Mr. Chu Sensei. This year I'm 44 years old already, getting older. So currently I'm teaching in the campus of the University Kebangsaan Malaysia under College Tingkatan 6 Tuanku Mukhris. I have 22 teaching years experience, which I started to teach from 2003 until 2025. So this is a little bit about my experiences. I used to be a national trainer for chemistry new syllabus, also examiner for section B and C, national moderator for school base, and then motivator and lecturer that give talks about STPM chemistry and technique of how to answer. I also wrote a few books. Okay, so thank you very much for supporting. Aim for Ace STPM Chemistry for Sem 3 is out already. So for semester 3, if you can, please support me and buy one copy from me through my Shopee lah. Okay, and I also have my own blogspot, though this blog is already not so updated. So I'm mostly now on the YouTube channel here lah. Okay. Okay, so scheme of assessment as usual, you have already set for paper 1, which is during the semester 1. I'm sure that you have familiar with it. So as usual, 3 sections: section A, section B, and section C. And I think I've already shared with you the technique of how to answer the how to this one lah. So for section A, I will recommend between 20 minutes. Okay. And then for section B, I also recommend 20 minutes. Okay. Then for section C, you have a 25 minute for each question lah. Because in here, we have 15 mark and 15 marks, so altogether 30. So if you look at the marks distribution in here, you should be able to use almost equal time to solve each of the sections in here. And then for paper 4, you will get 20 marks in here lah. Okay. Okay, so without further ado, let's have a look at the questions that I prepared for you. Let's have a look at section A. So answer all questions in these sections. So you should not spend too much time on answering advisable maximum. I think I left out one. Okay, so are you ready? Yeah, so let's have a look at the question, shall we? Okay, so question number 1. Gaseous oxide of nitrogen has positive enthalpy change of the formations in here. So has positive enthalpy change of formations. So which factor is likely to make the most significant contribution to these enthalpy changes? So anything, the equation in here will be reaction of nitrogen oxide can generally be given below. We have half nitrogen plus X over 2O2 give NOx. So what is this trying to say is enthalpy change of formation is mostly endothermic. So why is it enthalpy change is mostly an endothermic process? So this is due to you have to break the short and strong triple bond, which require high bond energy lah. Okay, so that is why in number 1 the answer is A, because we want to break a high bond energy of the nitrogen molecule. So that is why you require excessive amount of the energy in here. Okay, right. So this is for number 1. Okay, if you have any question, you can just, I'm not sure whether you can speak out or not. I don't think so. So I have to look at the comment, but please leave your comment until the end of the section, okay or not, so that because now I'm in the blank mode. What does it mean by blank mode is that I can only see the screen right now that I'm looking at, but I cannot see your comments. So if you have any question, you reserve it, and then later at the Q&A sessions, you can ask any questions that you want. Is it okay that I do like that? Okay. Okay, please pardon me lah, because I really face difficulty in here lah. Okay, so sorry for that. Okay, so we move on to the next one. So number 1 is A. Okay, number 2, standard enthalpy change for the reaction 2NF3 to give 2N plus 6F. Delta H is positive 1668 kilojoule. What is the bond energy on the NF in here. Okay, so first of all, you need to understand how does the Lewis structure looks like. So 2NF3, which is look like this, give 2N as 6F. Delta HF is equals to positive 158. So if it is 1, so you divide everything by 2. So this one also you divide by 2 lah. Okay, so you have 1 NF3 give 1 N and 3F in here. Okay, so you have half of it, which is positive 834. But inside here, since you have 3 NF bond, do you see that? So you have 1 NF bond, 2 NF bond, 3 NF bond. So that is why you divided by 3. And with that, the bond energy in between the NF is positive 278 in here. Okay? Okay, cannot understand. So if you cannot understand, you try to type out your questions in the comment. If I solve it, I will try to look back lah on it. Okay? Can I? Alright, so this is for question number 2. If I'm too fast, you can always slow me down. Okay, then number 3, propanone has the molecular formula of C3H6O. Enthalpy change of combustion for hydrogen is negative 286. Enthalpy change of the combustion for carbon is negative 394. And enthalpy change of formation for propanone is negative 242. So using this information, what is the enthalpy change of combustion for the propanone? Actually, in here, try your best to understand that in the combustion of the hydrogen, basically is H2 gas plus half O2 gas. You still give H2O. Okay, so you still give negative 286. In the combustion of carbon, carbon when burned, you give a carbon dioxide gas in here. Okay, so you get negative 394 lah. However, if you notice carefully, the enthalpy change of combustion in here is actually the same with the enthalpy change of formation for H2O. Same goes with the combustion of carbon. It is actually the same with the enthalpy change of the formation for CO2. Just that the style of how they ask the questions is a little bit different. But actually, no matter you are talking about formation of water or combustion of hydrogen, they are the same thing. Or you are talking about formation of carbon dioxide or combustion of carbon, they are actually the same thing here. Okay, so what is the enthalpy change of combustion for propanone? First, write the equation for the combustion of propanone. You have C3H6O plus 4O2 with 3CO2 plus 3H2O. Then you can use total enthalpy change. Total enthalpy change of, because this is objective, you try to do it as fast as you can. Okay, so you use total enthalpy change of the reaction is equals to total enthalpy change of product minus total enthalpy change of reactant. So you have 3 times negative 394 plus 3 times negative 286 minus negative 254 plus 4 times 0. So you get your enthalpy change of reaction, which is actually combustion, is equals to negative 1786 in here. Okay, so with that, that is how you are going to solve for this number 3. Okay, all right, so there you go for question number 1 until question number 3. Any questions that you can't understand and would like me to repeat for you? You can type at the comment there if you have any, so that I can answer to you immediately. Yeah, so I do not see any questions on the comment part. So I guess you all can understand so far. Okay, okay. So let's continue. Okay, then immediately we goes to number 4. Below are the standard and electrode potential E0 at 298 Kelvin for several copper and iron species. Okay, so you have Cu2 plus gives Cu positive 0.15, Fe2 plus Fe negative 0.44, Cu2 plus Cu positive 0.34, and Cu plus Cu positive 0.52. And then you have Fe3 plus Fe negative 0.04, and Fe3 plus Fe2 plus positive 0.77. So this is one of the methods of how they want you to they express the standard electrode potential for the system in here. Okay, so based on the information above, which of the following is correct? Number one, copper is the strongest reducing agent. Is copper the strongest reducing agent? So how to read if it is the strongest reducing agent? You always read is you look for the most negative or least positive lah. Then you look at the species at right. Okay, so in this case, is copper the strongest reducing agent? No. So if you follow the instruction that I give to you, so you look for the most negative. So in this case, this is the most negative. So, and then you look at the species at the right, which is iron. So instead of copper, it is the iron that is the strongest reducing agent. Therefore, A is false. B, Fe3 plus is the strongest oxidizing agent. Do you agree? So for the strongest oxidizing agent, conversely, you look for the most positive or the least negative. Then you look at the species at left. So which one is the most positive? Among all these choice, this is the most positive. And what are the species at the left? Fe3 plus. Okay, so Fe3 plus is the strongest reducing agent. B is correct. C, CO2 plus is able to oxidize Fe2 plus to become Fe3 plus. So this is about spontaneity of reactions. So in here, there are two cases. Either you say Cu2 plus 2E minus gives you E naught is equals to positive 0.34. Then you have Fe2 plus give Fe3 plus E minus. So E naught is equals to, now you already reverse this equation, isn't it? Okay, so it becomes negative 0.77. So your overall equation in here, so you shall have Cu2 plus 2 Fe2 plus give 2 Fe3 plus Cu. So the E naught cell is sum up lah, is equals to negative 0.43 volt. So since reaction is negative, it is a non-spontaneous. So therefore C is wrong lah. Okay, C is wrong. Okay, and then finally EMF of the cell between Fe and Fe2 plus. So this is the anode, Cu2 plus Cu, this is the cathode. So you use E naught cell equals to E naught cathode minus E naught anode lah. So you get positive 0. You have a negative 0.44. Sorry. Erase this. So here, use eraser. Okay, so you have the cathode. So what is the cathode of the reaction? So the cathode in here is the what? Cu plus and Cu, positive 0.52 minus Fe2 plus Fe lah, negative 0.44. So your E naught cell is equals to positive 0.96 volt. So since the 0.96 is 0.08, so this is wrong. Okay, so D is wrong. So the best answer in here is boy. Okay. Okay, cannot understand number 4. Sir, for question 2, isn't the reaction is reversed for enthalpy change? Shouldn't be bond negative to be negative. No. Bond energy is always positive. Bond energy is always positive. Okay, so cannot be negative 1. Okay, and why are we going to reverse that? No need to reverse. Okay, no need to reverse. Okay. Okay, can Okay, so I've already solved in details. So if you cannot understand later, you can browse back lah. Okay. Okay, number 5. Which of the following is true regarding the setup of standard hydrogen electrode? So in here, our standard of hydrogen electrode, if you use 1.0 mole of sulfuric acid, you produce 2.0 mole of the H plus ion. So which is actually wrong. So the temperature is fixed at 273. They are measured at 298. So K is wrong. So the E0 for the hydrogen electrode is arbitrarily fixed at 0 volt. So the black platinum or simply platinum is coated on the surface to facilitate the absorption of the hydrogen. So therefore C is correct. And then the pressure of the hydrogen is 101 kilopascal, not 1.0 kilopascal. Okay, so the answer for number 5 is C. Okay. Okay, so Ken. Okay, so with that, that is how you are going to answer for number 5. Huh? Any questions so far? Okay, so if no problem, then we go to number 6. Now, number 6 is very challenging. Standard electrode potential of the copper and argentum are given below. So Cu2 plus Cu E0 is positive 0.34. Ag plus Ag E0 is positive 0.80. The following cell set up to obtain pure copper by electrolysis as shown below. So this is the copper silver alloy. So this is the pure copper. So this is the cathode. This is the anode lah. Okay, sorry, terbalik. sorry. Wait. This terbalik. Sorry, draw wrongly. Terbalik. Okay, so can I recorrect this one, the statement? Okay, so this is the anode. Okay, this is the cathode. Okay, so anion attracted anode, cation attracted the cathode in here. Okay, so here comes the questions in here. Okay, so when a current of 40 ampere is flow through the electrolyte for 26.8 minutes, the mass of the anode decreased by 26.47. What is the percentage composition of copper in the copper silver? Okay, so in this case, because you have a mixture, and in here, anode is going to decrease, corroded lah. They are going to corrode, whereas the cathode, they are going to be coated with a layer of metal lah. So here comes the question, because in here it is made up of the copper, silver, this one lah. Okay, so an anode, the one that is readily to be corroded is copper first or silver first. Now you have three E0 cells in here. Because you have copper sulfate, so you have sulfate ion, you have water, and then now you have Cu2 plus Cu equilibrium. Okay, and then you have the silver also inside here. Okay, Ag also inside these molecules in here. So which one will be selected at anode? So at anode, we choose the one which is the least positive. So in here, copper is the least positive, therefore copper will be corroded first. Okay, so in here, the equation in here will be Cu2 plus 2E minus gives Cu. Okay, after no more copper, then the next to corrode is the silver. So when copper will be corroded first. Okay, copper is corroded first. Okay, so that is why what falls in the 26.47 here is mainly copper, then little silver. So here comes the question, what is the percentage of composition of the copper in copper silver alloy? So you use Q equals to IT. I'm so sorry because I don't know how to move this. Okay, so Q equals to IT, and then you have Q equals to so yeah, you have to erase first. Okay, so later you can browse back the slide there. Okay, so copper will be first corroded, okay, or will be first erased in here. So then mass of the copper dissolved is 63,200 divided by 6.3 over 2 times 99.5. So mass of copper dissolved is 21. So so sorry to be so fast. And now you have Q equals to 64,000, isn't it? Then mole of electron is equals to 64320 divided by 96,500, and then which is equals to whatever value lah. Okay, so since two electron is to one copper, so mole of copper is divided by 2 lah. So mass of copper, you multiply with the RMM, you get 21.16 gram. Okay, so after you get 21.16 gram, you divide it by 26.47 times 100%, so you get 80.0. So that is how you are going to solve for D in here. So in STPM, there will be one question which is very difficult one. So this is the way of how the challenging questions is asked for number 6. Usually it's for number 6. So is it possible to slow down? Okay, I try to. Sorry. Okay, I try to slow down a bit. But I've already attached the slide in the comments there. You can look at the answer inside there. I've already attached. Basically, no need to copy anything lah, because everything is there already. So you just here to check your answer only. Okay. But if I'm going too fast, so I'm so sorry lah. And for those who are asking, hey teacher, why copper is corroded first rather than silver, you can go to my YouTube for the chapter 2 when I teach about the electrolysis to get more information there. Okay. All right, Ken. So that is how you are going to solve for number 6. Now, due to time constraint, I cannot go very, very slow. Okay. But technically, that is how you are going to solve the problems in there. Okay. Can. Okay, so that is for number 6. Can. So let's go to number 7, shall we? Yes, you can rewatch the video back. Yes, this one is on the YouTube permanently. Okay. Okay, so which of the following is true regarding electrolysis? A. Electrons flow from cathode to anode at the external. No, it is always anode to cathode. Okay, anode to cathode, not cathode to anode. So B. Electricity is conducted through electrolyte by electron. So electron flow from the positive to the negative terminal. Okay, so B is wrong. C. The ease of discharge of metallic cation is inversely proportional to the reactivity. So the aqueous ions conduct electricity through the electrolyte. So therefore C is wrong. Okay, and then amount of the substance produced during electrolysis is directly proportional to the quantity of charge. So in here we say that when you have because when you say Q equals to IT, so and then Q equals to IT, and then eventually mass of the substance is directly proportional to the Q. Okay, so when you have a higher quantity of charge, you have a higher mass. So this is stated in the Faraday's first law. Okay, this is stated in the Faraday's first law. Okay, so so the answer in here is D . Okay. Okay, Yu Yong, can I answer your questions at the end of the Q&A there later? Because you are now asking the things which are not related to the things that we're going to discuss. Later at the Q&A sessions, I will answer your questions, can or not? Okay, Yu Yong? Okay. Okay. So number 8, the first 4 ionization energy of the 4 elements are shown below. So you have PQRS. Which statement is true about PQRS. So you have to first determine which group does it belongs to by looking at the large gaps in here. So let's start from P. So P, you look at the first and second is plus minus 1,300. Okay, second to third is plus minus around 900, but third to fourth is plus minus around 8,900 lah. Okay, so in here there will be the large gaps. So therefore P is belongs to group 13. As for Q, from first to the second, the large gap is around plus minus 2,600 lah. Okay, from the second to third, the difference is plus minus 1,500 lah. And then from the second to third, the gaps is almost 1,200 lah, isn't it? So in here, this is the large gaps in here. So when the large gap is between the first and second, Q is group 1. And then for the third one, R, so 700 to 1,400 is plus minus 700 lah. Second to third is 1,004 to 707, you get 5 plus minus 5,200 lah, isn't it? And then the third to fourth is around 2,800, isn't it? Plus minus. So this is the large gaps that you have in here. Therefore, R is probably group 2. And then finally, for S in here, 4,109 to 4,016 is plus minus 4,000. Okay. Then 6,009 to 4,500 is plus minus 2,400. And then 6,009 to 9,005 also plus minus 2,700. So this is the large gaps in here lah. So in another word, S is also group 1. Now between Q and S right now, both of them are group 1, but because this one has a lower first ionization energy, therefore you have a lower position. Okay, so this one has a higher, this one, so you have a higher position. So this is how you are going to read. So STPM question will not ask until here. They will not stop at the, this one. But sir, for Q70, is the amount is inversely proportional to the charge, right? Let me check back, sorry. The amount of the substance produced during the electrolysis is directly proportional to the electrical and the charge of the ions. Okay, let's us check back again. Electron flow from cathode to anode is wrong. B, electricity through the electrolyte by electrons, not electrons, but ion. So B is also wrong. The easiness of discharge of metallic cation is inversely proportional to the reactivity. That means the less reactive, the easiness of the metal ion is inversely proportional to the reactivity. The least reactive, easier to react, easier to charge. Technically is correct. Cathode, for cathode, we choose the one which is the most positive or the least negative. Yeah. So for number 7, the answer is C, not D. Sorry. The answer is C. Okay. Why? Because at cathode, okay, at cathode, we choose the one which is the least negative or more positive. So if let's say you have in between, let's say lithium plus lithium is negative 3.05, sodium plus sodium is negative 2.71, and then potassium plus potassium is negative 2.87. So in here, sodium is easier to discharge compared to lithium and potassium because it is the least positive, least negative in here. Okay, so if you throw lithium ion and sodium ion inside it, so sodium will be easier to discharge. Okay, so number 7, the answer is C. Thank you very much for helping me. And then this one, it is wrong because as you mentioned just now, yes, the charge of the ion, this one is inversely proportional. Inversely proportional. So this is the second Faraday's law. Okay, second Faraday's. So D is wrong. So the number 7, the answer is C. Help me to correct that. Thank you very much, Alex. Okay. Sorry, I overlooked the matter in here. Okay. Okay. So this is number 7, number 8. Okay, back to number 8. So in here, let's have a look. Q is more electronegative than S. So if Q and S, when going down to the group 1, okay, when going down to group 1, electronegativity or ionization energy all decrease. So when you have a lower positions, so Q has a less electronegative, not more. Okay, so A is wrong. B, melting point of S is higher than R. So S is group 1, R is group 2. So R will be higher than S. So S is lower, not higher. And then enthalpy of vaporization of Q is higher than R. So Q is group 1, R is group 2. So it also supposedly to be lower. Okay. And then the oxide of Q is more basic than oxide of P because Q is group 1, so it's usually more basic. So D is correct in here. So the best answer in here is donkey D. Okay. Okay, so that is how you are going to answer for question number 8 in here. Can? So that is how you check your answers towards which one is more the positions inside the periodic tables, okay? And based on your understanding of the trend for in between elements when going down to the group and when going across the period, you should be able to deduce all of it, okay? Okay, so that is for number 8, okay? So let's go to number 9. The first ionization energy generally increase across the period of the periodic table. Which statement explain why first ionization energy of phosphorus is lower than that of the sulfur in here? So if you look at the ionization energy trend across the period for period 3, so you have like this, aluminium, silicon, phosphorus, sulfur, chlorine, and also argon. Okay, so you have Na, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and also argon. And in here, between phosphorus and sulfur, phosphorus seems to have a higher ionization energy compared to sulfur. Now, there are two ways of how you explain why phosphorus is higher than sulfur. The first one, you use the facts that phosphorus, because it's 3s2 3p3, so you have a half-filled 3p orbital. So half-filled 3p orbital has extra stability lah. Now this is from the angle of the phosphorus in here. Okay, this is the angle of the phosphorus in here. Whereas for sulfur, from the angle of the sulfur, how are you going to explain that why sulfur has a lower ionization energy? Now, because if you notice this carefully, this sulfur has a pair of the electron. So you have a mutual repulsion in here. Okay, between the two electrons. So that is why phosphorus has a lower ionization energy because it's easily repelled. Okay, it experiences a greater electrostatic repulsion. So that is why your answer in here is it. Now this is an alternative way to explain why it said that phosphorus has a lower ionization energy compared to sulfur. Sulfur has a lower ionization energy compared to phosphorus. Sorry. So that is how you are going to answer for question number 9. Okay. Okay, any questions so far, Ken? I'm so sorry if I'm going too fast. Okay, so I hope that you can bear with me. Okay, then let's go to number 10. Strontium is an element of group 2 of the periodic table which is situated between calcium and barium. Which statement is true? So inside the periodic tables in here, okay, in group 2, you have magnesium, calcium, and then this is your strontium, this is your barium in here. So strontium is in between here lah. Okay, A, strontium has a higher charge density than calcium. So when going down to the group 2, strontium has a larger ionic radius compared to calcium, therefore lower charge density, not higher, lower charge density. So A is wrong lah. Okay. B. And then strontium sulfate and cause both lattice energy and the hydration to be lower, hence less soluble than calcium sulfate. So what barium sulfate is, strontium sulfate is less soluble than calcium sulfate. So B is correct. And then C, strontium carbonate and sodium nitrate are more difficult to decompose than barium carbonate or barium nitrate. Why? Because they have strontium has a lower thermal stability than barium. So this one later in the essay question number 19, I have the keywords of how you are going to explain such essay questions. So let's wait until that, then we'll discuss together, shall we? Okay. Okay, so in here, the best answer for number 10 is B. Okay. Okay, just now Harif asked, when do I use subshell and when do I use orbital? Subshell is orbital, same thing. Okay. Subshell is also orbital, same thing. Okay. Okay, number 11. Which of the following oxide of group 14 element is the least thermally stable? So the least thermally stable is lead, because lead is more stable than +2, hence PbO2 will decompose easily to PbO. Now this is a very quick to answer questions in here lah. So it is easily understood that when going down to the group, stability of the +4 decreased, whereas stability of the +2 oxidation state increased. So that is why anything that has something to do with lead at the +4 oxidation state will be easily decomposed to become a more stable +2 oxidation state. Okay, so that is why lead is the least thermally stable. Number 12, which of the following is true for carbon dioxide and carbon monoxide molecule? 1, the molecule are polar. Is it true? No. So CO is polar while CO2 is non-polar. So I've already drawn the Lewis structure for you between CO and CO2. So you can see that CO is polar because O is more electronegative, while CO2 is non-polar because the polarity pull oppositely, hence repel each other. Okay, okay. And then number 2, carbon atom undergoes sp. As you can see in here, both of them are undergoing sp hybridizations. So therefore, number 2 is correct. And then number 3, there are pi bond and sigma bond between carbon and oxygen. As you can see, carbon monoxide has 2 pi bond, 1 sigma bond, whereas carbon dioxide has 2 pi bond, 2 sigma bonds in there. Okay. And last but not least, both of them are acidic. Is it true? No. Carbon monoxide is neutral while CO2 is acidic. Okay. So only 2 and 3 are correct. Therefore, number 12, the answer is B. Can? Okay, let me see any questions. Okay, then number 13. S13 is the element of group 17 in the periodic table. What is expected for the S13 at 25? Now, if you look into the gases, especially chlorine, bromine, iodine, chlorine is a yellow greenish gas, bromine is a reddish brown liquid, iodine is a black solid. So S13, which is below the iodine in here, where is this one? So S13, which is below the iodine in here, will also be black solid. Okay, black solid. So it is a black, it is a solid, And in terms of the strength of oxidizing agent, when going down, the oxidizing agent strength decrease. So it will be a weaker oxidizing agent. Okay. So the answer in here is A. Very straightforward in here. So that is for number 13. Okay, and then number 14. Okay, listen carefully to the questions. An aqueous solution of sodium chloride, okay, concentrated ammonia solution, and also potassium iodide are added sequentially to silver nitrate. Which of the following graph represent the height of the precipitate? Okay, so in here, when you add that to potassium iodide will have the highest height. Why? Because KSP is the lowest. This one, I'm so sorry, but you have to remember a little bit in here. So in between AgCl, AgBr, and AgI, so the KSP decrease. Okay, so when you added to these three, Ki will have the highest peak. So this one correct, this one correct lah. B and C is already wrong. Okay, when you added to NaCl, NaCl will be higher than that of the lower than that of the Ki. So both A and B is correct. And the last decision lies to the ammonia in here. In this one, so when silver ion react with the ammonium ions, you form a complex of Ag and H3 which are supposedly a colorless, a clear solution. So when you have a clear solution, you shall have no precipitate. Okay, so this one is correct. Therefore, your answer is A. Okay, so that is for number 14. Number 15, transition element has the variable oxidation state in the complex ion. Which are the correct oxidation state of ion in the following complex? So FeCN2 SCN2 plus and FeEDTA2 minus. So this one you have to calculate one by one. So FeEN2 plus SCN2 plus is made of Fe plus 2En plus 2SCN is equals to plus 1. Fe is what you want to find. En oxidation state 0. The charge is 0, SCN is -1 equals to +1, so Fe is equals to +3. So it's either this one or this one. And then in Fe EDTA, so Fe plus EDTA is equals to -2. So Fe plus -4 equals to -2. Fe is +2. So number 15, the answer is C. Okay, so there you have all the objective question from number 1 until number 15. I've already answered for you. So how many objectives that you get it correct? Now it is common for you to wrong one or two, so don't worry about it. So it's not like we all wanted you to get 15 over 15, but just try your best to answer as much as you can. Okay. All right, so is there any questions that you want to ask for number 1 until number 15? You want me to repeat for you before we move on to the next sections? Wrong 7, never mind. Still, I can have some hopes in the uh, structure and essay lah. Well, I hope that my explanation is clear enough for you to understand on how to tackle the objective questions in here lah. Actually, objective is considerably important lah. Okay. All right. Any questions? Okay, so if no problems, we are about to move to the next section, shall we? Can I? Okay, so let's move on to the next section, which is the section B of the questions. Answer all questions in these sections. So you are advised to spend 15 to 20 minutes in answering this section. So answers should be short and clear, and do not over focus in one question. Means that if you structure is very straightforward. If you know how to answer, definitely you know how to answer. If you don't know how to answer, then give yourself some time. Don't like over focus. Don't think too much about what question. How to do this? I macam tahu, I macam tak tahu. I know seems to know, but I seems to don't know. So don't do that. Don't struggle for one question. Move on to the next one. Who knows, the idea might come later. What? Okay. So the key in here is don't over focus on one question. Okay. Okay, so let's move on to number 16. Now, why do I choose fuel cells in this in our lessons in here? Because fuel cell has never comes up in STPM chemistry before, throughout the whole new syllabus from 2013 until 2024. So I and then the new syllabus don't have fuel cell, if I'm not mistaken. So that is why if they have any question, I worry that they might ask in here lah. So let's have a look at question number 16, where I purposely trigger the fuel cell to ask you. A hydrogen oxygen fuel cells currently used to generate a voltage about 0.9 volt at a temperature between 70 to 140 degrees Celsius. A. Write the equation at cathode, anode, and overall equation for the hydrogen oxygen fuel cell. I'm so sorry, I didn't attach some of the standard electrode potential inside my question, and I expect students to memorize themselves. In the actual STPM examination, they will definitely give you some standard electrode potential for you to choose. So I'm so sorry for this case because I didn't lay out in here. But to be honest, I hope that students do memorize a little bit about the this hydrogen oxygen fuel cell. Now, there are actually two sets of answer in here. Fuel cell in here can be using this as a cathode. O2 plus 2H2O plus 4E minus give 4OH minus. Anode is 2OH minus plus 2H2O give 2E minus. So in here, you can multiply by 2. Okay, so this one times 2 lah. Okay, so you have 2H2 plus 4H minus give 4H2O plus 4E minus. So you cancel lah, 4E minus 4E minus 4OH minus 4OH minus 2H2O cancel with 2H2O, you get 2H2O. So your overall is 2H2 plus O2 give 2H2O in here. Now there is an alternative answer for alternative equation for that. The alternative equation goes like this. If you use an acidic one, it should be 4H plus O2 plus 4E minus. Give 2H2O, and then you have a 2H plus. You have a H2. Give a 2H plus 2E minus. Okay, so this one multiply by 2. So you have 2H2 plus 4H plus 4E minus. So you cancel 4E minus, 4E minus, 4H plus, and 4H plus. At the end of the day, you still give 2H2. So both of them are accepted in here. The difference is this is an alkaline fuel cell. Okay, and this is an acidic fuel cell. Okay. Okay, so that is for 16A. Then 16B, calculate the voltage of the hydrogen under standard conditions. So in standard condition, you use E naught cathode minus E naught anode. So E cell is positive 0.40 minus negative 0.83. You get positive 1.23. If you use this equation, you should have E naught cell equals to positive 1.23 plus 0 lah. Okay, minus 0 not plus. minus 0 lah. At the end of the day, you still get positive 1.23 volt. So no matter you use acidic fuel cell or alkaline fuel cell, you produce the same voltage in here. Okay. And number C, what are the advantages of hydrogen oxygen fuel cell compared to other chemical cell? So you produce a non-toxic product, which is water, and energy produced are cleaner. Okay. So that is how you are going to this one. Okay. Yes, physical state is a must. Physical state is a must in here. So all of them must write the physical state in here. Okay. In chapter 1 and chapter 2, we stress on the physical state. Thank you, Mr. Go, for helping me to remind the students. Because sometimes in my answer, I accidentally forget to write the state of matter. So in here, you must write the state of matter for chapter 1 and chapter 2. Lah, okay? Okay, so that is for this one. And at that year, there is also another alternative answer, which is lightweight. Yes. So another alternative answer at that year is lightweight. Okay. Okay. For question 16C, do not cause same as the non-toxic product. Same. We will consider as the same answer. Non-toxic product. Teacher, can we just memorize one of the cases? To be honest, to be honest, I have to recommend students to write both of them. Okay, so if can remember, but don't worry, in STPM, the question itself will give you the standard electrode potential equations. They will give you, but they will not just give you specifically one, two. They will give you a series of standard electrode potential. If you look at STPM 2015 Sem 2 Ulangan, they will give you a lot of equations like that so that you go and choose for yourself what is the best. Okay. Okay. Harif asked, for writing half equations separately, do we have to multiply the equation so that the electron to be the same, or you can write the simplest form? Yes, you have to balance the electron using lowest common multiple, because how many electrons donate, that is equivalent to how many electrons accepted. So yes, you need to multiply the necessary equators to the questions in that to the equations. Okay. Okay. Any else questions that you want to ask for number 16? Okay. So hopefully no problem. So if no problem, let's go on to the next one, shall we? Okay. Hey, hey, hey. Okay, so let's go to question number 17. Okay, question number 17, I purposely set transition elements. To be honest, the transition elements in the coming series, in the current new syllabus, they already remove a lot of the objective of the question, especially when it comes involving color. So I personally, this is all from my personal viewer. I might be wrong, and all the questions that I set in this paper is just based on the what is my prediction for the coming 2025, and it may not be accurate, so don't think that Mr. Chu questions are very accurate one. Please do not think like that. I just wanted you all to this one. Of course, you have to try various examples of the questions so that you'll be able to answer even better. Okay. Okay, question number 17 sounds like this. M2O3 is added to glass to give the glass a blue color. A. State in which block of the periodic tables does element M is located. So which block does it belongs to? You must mention that it is a D block lah. Okay. Okay. Number B. Valence orbital of M3 plus has 6 electrons. Write the valence electrons of the M3 plus, hence M atoms in here. Okay, so the valence orbital has M3 plus has 6 valence electron, and you already stated that it's d block, isn't it? So you must mention that the valence electrons for M3 plus is 3d6, whereas atom M has 3d7 4s2 lah. So you can also write 4s2 3d7, no problem, same. Okay. Okay, so that is for number B. Okay, is it too bright? Okay, then number C. Which of the following answer in B name element M? So from here, if you look carefully, it is cobalt. It is cobalt in here. Okay, it is cobalt. Okay, and then why 2 times C? Actually, this is supposed to be D. Okay, typing error lah. Sorry for that. Okay, D. Explain why M3 plus is blue. So at the end of the day, they want you to explain why is it M3 plus is colorful lah. Okay, so how are you going to explain that? Because you have 3 marks, so you must have 3 keywords. Number 1 is you must mention M3 plus has a partially filled 3D orbitals. Okay, so ions can be colorful. You must, in order for ions to be colorful, you must have a partially filled 3D orbitals. Okay, so when the so that when ligand is attached to the center metal ion and you form a complex ion, the orbitals split into 2 energy level. The orbitals split into 2 energy levels. Okay, so that is the second keyword. Okay, and then as visible light pass through, some color is absorbed, the electronic transition occur. So that is the third keywords. Therefore, form blue solutions. Okay, or blue color lah. Okay. So first keyword, M3 plus has partially filled 3D orbital. Second keyword, when complex ion is formed, the orbitals split into 2 energy levels. And then the third one is as visible light pass through, some color absorbed, the electronic transition occur. Okay, so that is the 3 keywords that I hope that you must be able to write down whenever you are trying to explain why is a complex colorful. And then for the last one, what color were absorbed by M3 plus? If you look at the color plate, so you must absorb orange in order to see blue in here. So teacher, how are we going to memorize this? So if you look at the 7 color of the rainbow, 7 color, actually it's 6 color lah, not 7 color of the rainbow in here. You among the 6 colors inside the rainbow in here, you split into 6 like this. Okay, so if you remember what is the Mr. Chu punya line tak cantik you pandai-pandai lah Mr. Chu, you are better than Mr. Chu in terms of this what drawing lah. Mr. Chu is a bad artist. Don't know how to draw very well. Okay, so in here, what are the 6 color that you have in the rainbow? You have first, you have red. Okay, and then you have the orange. Okay, Mr. Chu very patient, draw color for you, orange, and then you have yellow. Okay, okay, you have yellow. Okay, and then you have green. Okay, and then you have green, and then you have blue. And then you have violet. Okay. Okay, so in this case, if you want to see blue, which color that you want to absorb, you absorb orange in order to see blue. Okay, so that is how you see lah. If you absorb red, you see yellow green lah in here lah. Yellow green if you absorb red lah. Okay. So and then etc etc lah. You can go and find out by yourself what color you absorb to give what color. So this is the technique of how to know which color is absorbed to give which color lah. Okay. If you absorb yellow, you give dark blue lah. Okay. Blue violet is dark blue lah. Okay. If you absorb yellow, you form dark blue lah. Okay. So for more information, you can always go to my YouTube to check out the color absorptions in there. Okay. Okay. Any questions so far? Sir, is 3D54S1 wrong? Wrong. It is not 3D54S1. This one is based on the this one. Sir, can I say cobalt has vacant 3D orbital? It is not vacant. It is partial fill 3D orbital. So you cannot say vacant. You must have partial fill. A complex is colorless or white colorless solution, or you say a white solid when d orbitals is empty or complete fill. So that is why you must specifically mention that why is it blue? Because it has a partial fill 3D orbitals in here. Okay, they are very specific keywords. So I hope that you'll be able to get the keywords whenever you're trying to explain about why is a transition elements colorful. Okay. Okay, any else? But D block elements are I have a very strong feeling that this year D block element will come out in structure instead of the essay. But still, there might be chances it come in essay. Like I said, my prediction may be very bad. Okay, Mr. Yi can predict better than me. I hope Mr. Yi is with me right now. I mean, he can help me. Thank you also to Mr. Go that help me from time to time. Okay. By the way, you can always buy Mr. Go's Pelangi books. Mr. Go written together with four other very strong teachers in the Pelangi reference books, which you can get from the bookstore nearby you. Mr. Chu's books can only buy from Shopee. Okay. Okay, so can we go on to the next one? So that is for essay question number 16 and 17. Okay. So we go to section C, 30 marks. So answer only 2 questions. You're advised to spend 20 to 25 minutes per essay. Do your best to present in an essay full with content related to the question. Point form, table mind map is allowed in answering STPM chemistry, but we don't advise you unless you're really confident with your answer. So I really do hope that when you write essay, you write in the essay form. Don't write table unless you know what you are doing. Okay. Yeah. Okay. Okay, are you ready? Okay, so let's have a look at the questions that I'm about to discuss with you. Question number 18 sounds like this. Liquid hydrogen N2H4 is used as a rocket fuel because its enthalpy of combustion is very exothermic. The thermochemical equation for the combustion of the turbine is shown below. Okay. Okay, so you have N2H4 liquid plus O2 give N2 plus 2H2O in here. So delta, and I'm so sorry. Actually, I accidentally switched the mark. This is supposed to be 4. This is supposed to be 3. Mr. Chu made a very serious mistake in here. So, but never, regardless, you should try your best to look out for the marks in here. Okay. Again, I would like to apologize for all inconvenience caused in here. Okay. So, 1.0 gram of hydrogen is burned in the bomb calorimeter. Calculate the temperature change if the total heat capacity of the bomb calorimeter is 5.86 kilojoule per degree Celsius in here. Okay, now you have a very confused figure in here. Here is 2SF, here is 3SF. So, teacher, if you have 2 different significant figures, in here you have 4SF. So, teacher, so many different significant figure. Which one should we use for our final answer? for number one, we are referring question to question. We choose the one which has the least significant figure. So your final answer should have two significant figure. Okay, I repeat, if you have such as question like this, you have two significant, three significant figure, four significant figure. So you choose the one which has the least significant figure, which is 2 in this case. Okay, so how are you going to solve for number one? First, you calculate the number of mole for hydrazine. So 1.0 keywords are substitute as exactly given to you in the question, including relative atomic mass inside the periodic tables. So if nitrogen is 14.0, substitute as 14.0. Okay, and then don't straight away write 32 because we don't know where are your 32 comes from. You have to show us how you get to that 32. Okay, so 1.0 divided by 2 times 14.0 plus 4 times 1.0, or you get 0.3125 mole. Then mole Q is equals to mole times delta H. So 0.03125 multiplied by negative 534 kilojoule, you get negative 16.69 kilojoule. So the negative, the vector you can forget lah, never mind lah, because the theta which is Q over C, actually it's not theta lah. Nowadays they don't use theta, they actually use delta T. Sorry for that. Okay, the syllabus nowadays they use delta T instead of theta lah. Sorry for that. So please use delta T for your substitution. Okay. To be honest, I'm not 100% sure whether they still uses theta as the substitution or not. But just to be safe, I hope that you use delta T instead of theta lah. So it's 16.69 kilojoule divided by 5.86 kilojoule per degree Celsius. You get 2.9 degrees Celsius in two significant figure in here. Okay, so that is for number 18A. Okay, then number 2, calculate the enthalpy of formation for hydrazine is the formation of water vapor is negative 242. So you use total enthalpy change is equals to total enthalpy of product minus total enthalpy change of reactant. So it's negative 3, substitute as exactly negative 534.0 kilojoule equals to 0 plus 2 times negative 242.0 kilojoule minus x plus 0. So your x is positive 50.0 kilojoule. So in this case, even though, teacher, I thought you say that this is this is a 4 significant figure. This is also 4 significant figure. Why your final answer is 3 significant figure? Now, in this case, because we are using this formula, so we look at the final figure in here. If you look carefully, the final figure in here has 0.0 at its back, isn't it? So your final answer should also have 0.0. So teacher, I feel very confused. Now you sekejap say that you follow significant figure. Now sekejap you say that follow the decimal place. Which one you follow significant figure? Which one you follow the decimal place? My advice to the students is very straightforward. I say that if you use the series of equations like Q equals to MC delta T, mole is equals to mass over molar mass, this one, if you use the equations once to apply, then you have to look for the significant figure. But if you are just calculating enthalpy change, like H product minus H reactant, so you follow the decimal place given in the question. If the question has 1 decimal place, so your answer must also have 1 decimal place in here. So significant figure does not play roles in here. Instead, you look at this one. You see that inside their question, you have one sense of the formal uniformity inside the questions, and that is where students need to catch lah. I'm so sorry that STPM sometimes can be complicated like this, but that is the technique of how you are going to answer for them. Okay, I can only say like this in the talks like this. Okay, excuse me. Okay, so that is for number 2. Okay, you can alternatively solve like this. So you have the this one, you have N2 plus you have N2H4 plus O2. I didn't write state of matter, but you know what we are doing. Plus 2H2O. So this one is negative 534.0. And then this one, you times 2 water 2H2 plus 2H2O give O2 plus 2H2. Okay, so it is reverse reverse, so you get a positive uh, 484 lah, point zero. So you can start to cancel this one already. So terbalik. Aduh, Mr. Chu, sorry you use Hess law what I try to show to you is Hess law. Sorry, Mr. Chu, terbalik already the Hess law. Sorry for that. Mr. Chu sometimes can be very clumsy. Okay, so if you use Hess law, so it is you reverse the first equation. So N2 plus 2H2O give N2H4 plus O2. So it's negative 53.44.0 lah. Okay, and then for the water you have 2H2 plus O2 give 2H2O lah. This one is negative 242. This one is become positive already. 242.0 times 2 lah. Okay, so you get negative 484 lah, 0. Okay, so you can start to cancel 2H2O cancel with 2H2O, O2 cancel with O2. So at the end you have N2 plus 2H2 give N2H4. So you sum up, the answer is still equals to positive 50.0 kilojoule per mole. Okay, so the same question. So you can apply both methods in here. Either you use this one and then this one. So is it okay if I not put the unit during calculation but just fine? Yes, it is okay. It is okay for you to not to put the unit throughout the calculation, but final answer is the one that we are looking at. Yes, you can. Sir, can I write the number of mole in fraction if answer calculated has many decimal place? Final answer must be in significant figure. Throughout your calculation, you want to put in fraction, no problem. Okay, but final answer must be in decimal places. Okay. Yeah, I know that is a cheat code, but this cheat code is not applicable in STPM. Okay, B. Element P and Q form an ionic compound of PQ2. The enthalpy changes involved in the formation of this compound under standard condition are as follow. So you have all the enthalpy change in here. Calculate the enthalpy change of formation for PQ2. Are you ready? Okay, so you have to draw the Born-Haber cycle supposedly, I'm so sorry I forgot to mention that you must draw Born-Haber cycle, but 8 marks like this, definitely students must know that you must draw Born-Haber cycle Okay, so how are you going to calculate this? So always remember to put energy y-axis and then start off with putting this one 0. This one try your best to put 0 in here to show that this is the formation for PQ2. Then you have the atomization. Now your arrow must touch here sorry because Mr. Chu when you show you this slide does not touch, but you must at least show to touch to this ground. This is first and second ionization energy of P. So you form P2 plus Q2 plus 2E minus. Then you have 2 times the atomizations. Okay, so you form 2Q gas, and then you have 2 times electron affinity. So you form this one, and finally you have the lattice energy of PQ2. So each energy levels in here will give you 1 marks. So altogether 6 energy levels, 6 marks in here. Then you use the formula. Enthalpy change of the formation is equals to lattice energy plus atomization plus the atomization plus first, second ionization energy plus 2 times first electron affinity. So you substitute accordingly Enthalpy change of formation is negative 2180 minus positive 121, 2 times 1.21. So you get positive 580. Press your calculator, you get your enthalpy change of formation is negative 805 kilojoule per mole. Okay, so Born-Haber cycle is a very common in STPM, and the last time that was asked is quite some times already. So I hope that you'll be able to come up with the lattice energy. They are actually quite common in STPM. So make sure that if you see this question, solve this question and you get a very, very high marks, 8 marks. Okay, so please try. Okay. So questions. Teacher, the line need to attach to y-axis or not? What do you mean which line? Junhang? uh, the line actually you don't also can I understand already, you don't attach to y-axis also can, no problem, but you must have the zero there lah. Okay. Okay, one, I was told that line must not touch the y-axis. Why must I make it touch? Doesn't I don't know, must not touch y-axis. I don't know about that. I'm so sorry. Maybe my information is old already, but I don't think that it does. I don't know whether this information was old already. Yeah, I'm not 100% sure it should touch or not. So maybe if I overlook some matter and you follow the latest answers, the follows the latest this one, to be honest, I am not very well informed according to the latest one, 2023, because our latest report is 2023. We haven't have 2024 one. So maybe if I'm outdated, then you follow those experienced teacher lah. Okay, for me, it doesn't really matter. Sorry for that. Number two, for the enthalpy change in the diagram, can I ask write delta H1, delta H2, and so on? Or I would recommend students to use the appropriate enthalpy change symbol, or you can substitute with value. So because the value will represent the enthalpy change that you want to express it. So you can either substitute with value or substitute with the symbols requires in here. Okay, so should I also write the value in the diagram? Yeah, like I said, you can write value or enthalpy change. Okay, Alvin asks, sir, is the unit energy level diagram is kilojoule or kilojoule per mole? Kilojoule, not per mole. Uh, and then in the energy level diagram, do we need to write the physical state too? Yes, yes, physical state is extremely important, because the physical state, some of the enthalpy change involve the changes in the physical state. So state of matter is a must. All chapter 1, chapter 2, state of matter is a must. Okay, chapter 1, chapter 2, state of matter is a must. Okay. Okay, any else questions? So back to this one, if I'm not mistaken, it needs to touch the y-axis and the arrow need to touch in between the two lines. Yes, yes, yes. The arrow need to touch in between the two lines. Yes, you must touch between the two lines. That is why if you look at my slide, I add the additional, because when I do this PowerPoint, I overlook this matter. So now I try to cover back. Okay. For the value in the diagram, this reaction is the unit important. Because you already label your y-axis as kilojoule, you don't write your unit also, never mind. Okay. Okay, what else? Thank you very much for this one. Can I write first and second ionization energy separately? Yes, you can. Definitely you can. Yes. Yeah, can I? Okay, so with that, that is essay question for number 18. Is it too bright for you all? Because now the sun shines very brightly in here, in my room here. Okay. Later I show you my environment. Okay, so again, what axis should we write, enthalpy or energy? The latest one is enthalpy or energy. Macam I pernah dengar is energy. Macam pernah dengar is energy. Mr. Go, can you help me or not? Are you still in here? Can you help me to confirm is enthalpy or energy? I also heard about this enthalpy before energy. Now I'm so scared that my information is very, very outdated. That I cause this one if I cause any this one. Mr. Go, are you still in here or not? Mr. Go, can you please help me, because sometimes I'm lost. I need your help in here. From what I understand so far, you do not really need to this one. Okay. because I didn't memorize the answer very well. Okay, so far I have no information, but should be okay lah. Should be okay lah for both of them. Okay. Okay, so can we move on to the next one? One more. You said you can write the value, so I just write the number only, no delta H. Yes, 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 yes. Just write the value. Yes. Okay, it's energy. Yes, it's energy. It's energy. Okay. Okay. Can Okay, so let's move on to the 19. Decomposition temperature of magnesium carbonate and barium carbonate are 197 degrees Celsius and 1357 degrees Celsius respectively. Explain the relative thermal stability. Now, class, I tell you, if you ever see this question, please answer. Because the way of how you answer this is very fixed, very straightforward in here. Okay, explain the relative thermal stability of magnesium carbonate and barium carbonate. So try your best. If you ever see this kind of question, please try to answer. Now, what are the 8 keywords that you have to write whenever you are answering this essay question? So I just straight away shows you the keyword. If you are able to tell us these 8 keywords, and I can assure you, you are going to get a very good essay marks in here if you ever see something. So no matter you are asking for carbonate, nitrate, or hydroxide, they all give the same points in here. Statement number 1, you must first mention that barium carbonate is more stable than, is thermally more stable than magnesium carbonate. Yes. Then number 2, you must write the equation. So in this case, state of matter, if possible, try to write whereas the magnesium carbonate is solid. Okay, so this one is also a solid, this one is a gas if try your best to write. If you don't write, I think so far in organic chemistry they don't really stress about that Okay, then you must mention that size of the magnesium ion or ionic radius is smaller than that of the barium ions. Ion is important, you must mention ions is smaller than that of barium ion. Therefore, the magnesium ion has a higher charge density than barium ion. So try to use the one with a smaller ionic radius. Why? Because the next statement, when you say that magnesium ion has a smaller ionic radius than barium ion, you followed by magnesium ion has a higher charge density than barium ion. Therefore, magnesium ion has a higher polarizing power. So what can the ion with a high polarizing power do? The ion with a high polarizing power is able to distort the electron cloud of the carbonate ion is easily distorted by the small Mg2 plus ions in here, hence weakening the CO or rendering the CO bonds inside the carbonate. If nitrate, NO bond. If hydroxide, OH bond. So furthermore, magnesium oxide is more stable than barium oxide. So that is why magnesium oxide, barium carbonate has a higher thermal stability than magnesium carbonate. So you're able to write all these 8 key points. I'm very sure that you are going to answer very well in these essay questions. Okay, so try your best to get to this essay question if you ever see one. Okay. Okay, any questions so far? Okay, hopefully no problem. Then we goes to 19b. Solubility of the sulfate of the group 2 elements of periodic table are shown below. So this is this one. State and explain the factor that influence the value of solubility of the sulfate compounds. So first of all, you must mention that solubility of the group 2 sulfate decrease down to the group. Okay. So then you mention so you use the equation enthalpy change of solution is equals to hydration minus the T's energy. Okay, and then if you really worry, you might also want to add where the lattice energy is directly proportional to the charge, yet inversely proportional to the ionic radius, whereas the enthalpy change of the hydration is directly proportional to the charge, yet inversely proportional to the ionic radius, like this. Okay, so please distinguish the difference in here. In lattice energy, you have to both consider both cation and anion together. But for this hydration, you compare separately of the ion. So that is why the more negative the enthalpy change of solution, the more soluble the salts are. Okay, so as going down to the group 2 sulfate, the group 2 sulfate, group 2 ion increases. So this will cause both hydration and lattice energy decrease down group 2 sulfate. However, the enthalpy change of hydration decrease more significantly than the lattice energy. Okay, more significant than the lattice energy. That's due to the large of the sulfate ion. And I will also recommend you to write. So for beryllium sulfate and magnesium sulfate, okay, since enthalpy change of the hydration is greater than the lattice energy, so therefore enthalpy change of solution is exothermic, therefore soluble in water. And then conversely, for calcium sulfate and the barium sulfate. So you are going to say that since the T's energy is greater than the enthalpy change of the hydration, so enthalpy change of solution is endothermic, therefore sparingly soluble in water lah. Okay, so that is how you are going to add for the last two statements in here in order to help you to secure your marks better. But for you all, these are the keywords that you have to write whenever you are writing for this essay question. But and then actually here I wanted to ask about group 14 because in group 14 in the latest syllabus, silicate is already no longer in our syllabus, and then glass is never been asked before. And then tin alloy, tin and its alloy also didn't, we don't have in the latest syllabus. So they might also ask group 14 for that. So I hope that you take notes on the group 14 for silicate and also this glass and also the alloy of the tin in here. So they are actually quite common in STPM also lah. Okay. Okay. So any questions that you want to ask this one? So is temperature higher, thermal stability increase? Yes. When we say decomposition temperature is higher, that means you require higher temperature to break. So why you require higher temperature to break? Because they are more stable. Yes. So is it okay to write more sentences than the require? Yes, definitely. Yes, you can. You can write a lot. Silicate and glass. Sir, for 19B, if we write formula of delta H is equals to solution, can also get 1 mark. You have to write the whole equation. Enthalpy change of solution is equals to hydration minus lattice energy in here. Is H negative more soluble? Yes, if H is enthalpy change of solution is negative, the salt is more soluble. Yes. Stable than positive. It's not about stability, dear. It's more about solubility. You talk about stability when we look into formation. Formation, then we talk about stability. Yes. Okay. Can? Okay. So with that, that is for 19. Okay. So we are going to go for the final essay, which is essay question number 820. Halogen X and hydrogen gas react when heated in the presence of platinum catalyst to form HX. So when HX is dissolved in water, aqueous solution is formed. When aqueous silver nitrate is subsequently added to the solution, a precipitate which is insoluble in excess is formed. Identify halogen X and explain your answer. So this one from the following statement. The first one is already trying to tell you that it is the iodine already, because only iodine react with a platinum catalyst, okay? And when HF dissolved in water, so another statement that confirm X is iodine, silver nitrate form a precipitate insoluble in aqueous ammonia. Okay, so this is get confirmed that X is iodine. So based on all this description, you must mention that X is iodine, or you write the formula I2. Now you cannot say X is I, cannot. You must write I2 iodine. Okay, so then you write the equation in the reversible. Iodine plus hydrogen gas give hydrogen iodide. Okay, if platinum, then you this one is heated, then just put a triangle for heating. For heating in inorganic chemistry, you must put triangle. For example, just now the decomposition temperature, right, class? This one. If possible, this one also put a triangle, please. Okay or not? Uh, Triangle indicate heating. Triangle indicate heating. So you must put a triangle whenever involve heat. Okay, sorry for that. I forgot to mention. Okay, and then you must mention that a yellow precipitate is formed. The question only said precipitate, but what color of precipitate is the one that you must insist. So you must state that yellow precipitate is formed. So I minus plus Ag plus give AgI. And then finally, AgI cannot form complex ion with ammonia aqueous solution. So that is why it is insoluble inside ammonia aqueous solutions. Okay, so you are explaining your art statement in there. Okay. Okay, so this is for 20A. Okay, then for 20A2, halogen X dissolved in aqueous NaX solution and in trichloromethane. State and explain the observation for the reaction. So you have two observations. So iodine dissolved in NaI to form brown solution. Okay, so according to the equation, I2 plus I minus give I3 minus. This is the one that explain the formation of the iodine solution. And then iodine is a covalent compound and dissolved in organic solvent to form the purple layer. I forgot to add to form purple layer. And form purple solutions in organic solvent. Trichloromethane. Okay. Okay. So with that, that is for the answer for 20A lah. Okay. Okay, and last but not least, we have 20B. A solid halide react with concentrated sulfuric acid to form HQ gas, which is then oxidized to Q2 gas. The solid plays an important role in black-white photography. Identify solid halide and explain your answer and its role in black-white photography. Okay, so how are you going to identify? The moment that they say that important role in black white photography, you must know by yourself that the solid halide is silver bromide. Okay, so it is a silver bromide. So the solid halide is silver bromide, AgBr. Okay, so you have to explain your answer of what happened when dissolved in sulfuric acid. So when react with sulfuric acid, first concentrated sulfuric acid act as a Bronsted Lowry acid. According to the equation, Br minus plus H2SO4 give HBr plus HSO4. Then concentrated sulfuric acid act as an oxidizing agent. So when you have the equation 2HBr plus H2SO4 form Br2 plus SO2 plus 2H2O. So why can this happen? Because sulfuric acid, a concentrated sulfuric acid is a stronger oxidizing agent than bromine. So you must mention this statement. And then finally, explain its role in the black-white photography. So in black-white photography, when photon is absorbed by the silver bromide, silver ion will be reduced while bromide ion will be oxidized. So according to the equation, 2AgBr give under Hv, which is the photon, form 2 Ag plus Br2. So if you want, you can also add this statement. So Ag plus E minus give Ag. At the same time, oxidize, you have Br minus give half Br2 plus E minus in here. So can. Okay. So and with that, we have completely discussed all the questions inside this question paper. I hope that my explanation today helps you to understand on how to answer to these question papers. Okay, so now it's Q&A time. So feel free to ask any questions in here. Okay, Harry asks, is there such thing as wrong cancer right in the question? Let's say I give additional point for one statement wrong, but in schema I will get penalized. Unless the statement is contradicting. Sekejap you kata iodine, then you explain everything about iodine. Then sekejap you kata bromine, then you explain everything about bromine. Let's say lah, we will always look at the first one. We don't look at the second one anymore. Okay. So and then don't worry, you won't get minus mark. In STPM, there is no such thing as minus mark. No. Okay. It's just that has mark and don't have mark. That's all. So, but stability higher means less soluble, right? No. Stability has nothing to do. Which stability you're talking about? I'm not 100% sure. Can you re-highlight again? Okay. Any else questions? Okay, so I'm going to scroll back, and in one of the questions that I missed out earlier just now, somebody asked me about this. Yu Yong, teacher, can I ask if the question require us to find enthalpy change of reaction and the answer are derived from the standard electron affinity exp the delta HEA times 2? So for this case, do we need to put kilojoule or kilojoule per mole? Because you have already 2 times electron affinity, of course it's kilojoule, not kilojoule per mole. What does per mole means? Per mole means per 1 mole. Okay. Yeah. Okay. So I scroll down. Okay. Cheng Yu asked, sir, is there any key to memorize these equations since there are too many equations? I tell you, the best way to memorize equation is to practice. Don't memorize, but you must, hey, you memorize is one thing, and then knowing which equation is applied at which condition is another problem. So you have to do it together with the question. So no points of memorizing if you don't know where to apply. Okay. Okay, Pei Zhi asked, sir, when we want to describe atomic size across period, what should we say? Screening effect remain unchanged or not much increase? Okay, if now about this nuclear charge screening effect and effective nuclear charge in here, I have a few students who come and ask me, teacher, how to describe when going across period and going down to the group. I would say I follows the Raymond Chang's books. Raymond Chang's book says like this. When going across the period, nuclear charge increase as proton number increase, screening effect remain almost constant. Therefore, effective nuclear charge increase. Therefore, atomic radius becomes smaller when going across the period. And then when going down to the group, we say that nuclear charge increase while proton number increase. However, screening effect increase as more shell is used to filling in electron. However, due to the using more shell, this effective nuclear charge slightly increase. That is how the Raymond Chang's book written. And if you Google it, or if you ask ChatGPT or DeepSeek, they will also give you the same reason, because that is the way of how we answer toward that. So if there is any other way, to be honest, I'm not sure anymore. Okay, sorry, this is the what I can say in here. Question like 20, have to how memorize the theory and observation? Yes, you have. In inorganic chemistry, 4 important keywords is you must be able to describe physical properties and of course explain it. And then when it comes to chemical properties, you must be able to write equation, explain observations, and also describe all the observations inside there. Yes, so no choice. You have to really do a lot of practices. But at this moment, you just try your very best. Okay? Okay, thermal stability. Thermal stability in what? If you are talking about thermal stability of the group 2 nitrate or carbonate or sulfate, this is the keyword that you have to memorize in this explaining the thermal stability of the group 2. Nothing else already. These are the keywords already. Okay. Then the however, you should be able to distinguish when describing about this is for chapter 2 when you describe chapter 4, sorry, this is for chapter 4 when you describe about group 2. And then there is this when discuss about the melting point of the group 14. So group 14, you use atomic radius, let's say from carbon to silicon to germanium. Why is the melting point decreases? So you must use atomic radius, bond length, bond strength, because they are covalent compound. They are giant covalent structure lah. So you must use atomic radius, bond length, bond strength to answer that. Okay. Okay, Yan Kai asks, teacher, when writing Enoch cell, does the concentration of the aqueous solution need to write 1 mole per decimeter cube? Yes, you have to. So please, sketching the diagram is so basic, so simple that we have seen so many years keep on prompting on how to draw a chemical cell diagram. So please learn how to write. And every time when you draw, you must mention the condition, 25 degrees Celsius, 1.0 mole per decimeter cube, must mention. And then must also label anode cathode flow of electron. If the question require you to label where is the flow of cation and anion, cation goes to cathode, anion goes to anode. Okay. Okay, Alvin asks, sir, is the platinum electrode in the electrochemistry question, did the platinum electrode draw smaller or bigger? Size does not matter. Sunshine asks, can I write the point form just like sir doing? Try to avoid that. But point form for me is to highlight what are the key points. If I write very, very long essay and then I highlight the key point later, you're all confused. So I might as well write the key point. Okay. Things are like this. When studying inorganic chemistry, it is very important for you to remember all these key points because these are the essential points that you have to write whenever you write essay. So you just kembangkan the ayat sendiri lah. You write your own, use your own words to describe lah about all this. But all these key points must be in your essay. Okay. More negative one is only for standard, right? Yes. Okay. Okay, teacher, do you have any tips to memorize even the charge of the complex ion? If you see this kind of the question, group 7, let's say D block lah. Kalau dia tanya dalam bentuk struktur, kena jawab lah. Kalau dia tanya essay, jangan jawab lah. D block sangat susah. Okay. Sorry lah to say like this lah. But if you are very these D block elements, students who can understand, they will understand very well. Students who cannot understand, you macam mana buat pun very difficult, you know. So, nak cakap tips untuk memorize every charge of the complex ion tu, kena banyak latihan lah, kena banyak tengok semula lah. Sorry for that lah, Siti. Okay, sorry lah. Okay. So for definition, is heat energy of heat change. Heat is enough already lah. No need here. However, some keywords that require you to use the word energy, like ionization energy must use energy, electron affinity, lattice energy, all of them must use energy lah. Okay. So do we need to include physical state in chemical for chapter 3 to 7? Okay, if the question describe, then must. If the question also didn't describe the state, then you don't state also, never mind. Okay. Which is more accurate, screening or shielding? Same. Okay. Is that all for the question for section C? Must write equation. If involving equation, write lah equation. Yes, it's a must. Yes. Physical state only important chapter 7, chapter 8. Other than that, no point also. Okay, thank you very much for helping me. So what must you recommend as I do last minute as an A, B minus student, by the way? To be honest, I cannot recommend, but I just write your own short notes. Okay, write your own short notes. You can refer to my short notes. Inside one of the YouTube in here, I teach students on how to write the important point for every single chapter. So you refer to that. Inside my YouTube, I have that. Okay. So what is unit must be used in when you to draw bond-Haber cycle, kilojoule per mole or kilojoule? We only use kilojoule lah. We don't use kilojoule per mole. Other than kilojoule per mole. No. Because not every unit has kilojoule, but kilojoule must be there. Okay, kilojoule must be there. Okay. Okay, so for the reaction of HBr HI with concentrated sulfuric acid, their equation when the product of Br2 I2 is H2S, but the Br2 is okay. For bromine is SO2 plus H2O, Br2 plus SO2 plus H2O. For iodine is H2S plus 4I2 plus H2S plus 4H2O. So I don't know about some other reference books that this one. Okay. So which book is yours in Shopee? Absolute Guide and also Aim for Ace. But nowadays, Absolute Guide finished selling already, so only Aim for Ace. If you see Chu Sensei, I use my pen name as Chu Sensei. So, Chu Sensei. Okay. Any other Chu? Recently, yes. Some of you come and question me, hey, teacher, you write these books. The one in the blue color one. No, I didn't write that. It's not me. It's another Chu. I use my pen name as Chu Sensei. Okay. Other than that, I don't use that anymore. Okay. Any else questions? Thank you very much for support. Okay, going across period 3, properties of oxide changes from basic to acidic because one of the element become weaker. Can you explain this statement? Mm, I would say that change from ionic to covalent instead of becoming weaker. Ionic to covalent, okay? Not becoming weaker, ionic to covalent, okay? So for questions, just explain only how do I go about it, which point must I cover. Can you give me a more detailed questions? Okay, thank you, teacher. Good luck. All sayonara. Okay, thank you for listening. Sir, if Mg and CO3 is thermally more stable than Mg, CO3 is more stable than NO3. Yes, yes, uh, yes, because of higher charge in here. Sir, please get me into studying how strict are the MPM market. Don't scare yourself lah. Don't think too much. For me, don't think too much. Please don't think too much. Just do your very best. A, B, C, that is up to them already. For me, always believe 人定胜天. As if you do a lot of works, definitely you can do lah. Okay. What is exactly basic and basicity? I understand metal and metal oxide are basic. Not necessarily, but most of the metals are basic except for beryllium. Beryllium is beryllium except for beryllium. If aluminium is aluminium, beryllium and aluminium can react with concentrated alkali, but the rest of the metal cannot. Okay. Sir, is the reverse of lattice energy is a solubility of compound? No lah, no. Just use enthalpy change of solution is equals to hydration minus lattice energy. This one. I scroll for you. Sorry. This one. Enthalpy change of solution is equals to hydration minus lattice energy. Just use this one. Okay. How about the base strength of base? Now, okay, there is no general way of I can conclude that for you, Alex. Okay, if you go for group two, then a basic city of the hydroxide increase when going down to the group 2 oxide and hydroxide. Okay, and then if you are talking about across period 3, basic city of the oxide decrease. Okay, that's what I can tell you. Sorry, sir, the upload I cannot see. Everybody else can see. You look into the description of this YouTube. You click into that. It's next to the is next to the question link. There is also an answer link. Sir, for CO3, NO3, which one is more stable? If talking about thermal stability, CO3 is more stable. Okay, anything else? Okay, so if there is nothing else, I guess that is all for our talks today. Sir, for the question they ask energy cycle, can I just draw energy level diagram? Can, same. I actually recommend you all to only use energy level diagram. All these cycle things, don't know lah. Okay, welcome. Okay. Okay, Sophia. Okay, all the best, Sophia. Sophie, don't worry too much. Don't think too much. You all already done a lot enough already, and I want to apologize that I am not able to be by your all sides always. However, I pray to the best of you all. So please make sure that you all do well, lah. Okay. Teacher, when draw complexes, do we need the formal charge in the central metal ion? Just put outside the bracket. So far in the STPM, we recommend you all to put for complex. We put outside the bracket. But if you worry, then you just put at the respective metal ion. Okay. Mm. But we so far we only for complex. This is for complex. You put outside is okay. Okay. Okay, so Mr. Chu already langsai my hutang. I try my best already. So sorry until today I am only able to do the technique menjawab with you guys. So to those who miss it, you can always catch up back my recording in the YouTube. Okay, so I wish you all the best and good luck in the semester 2, dear finalists of the 2025. Okay. Okay, so see you all in next semester organic chemistry, which is the toughest chemistry. Okay, bye bye. Sayonara. All the best, 加油. Okay.